So very good morning. 36 of that. Right. Good morning, everyone.
Good morning, sir.
Okay, ma, thank you. So you can hear me. So welcome to this online artificial intelligence classes. And what is that we are doing for the last 4 classes is we are trying to connect what you have learned in the first and second, third units with an expert system. So I have been telling like we have started the expert system design in the first unit itself. Like when you try to implement this tic-tac-toe game in the terms of prediction in the third implementation, you try to develop a simple predictor. And if you see the second unit where you're talking about an A star algorithm, where the A star algorithm has a heuristic called as h of x plus f of x, where it is concerned about the distance between the starting nodes to the current node and current node to the goal node. So the latter part, like whenever it is doing something calculation with respect to the current node and the goal node, that is called as a prediction actually. So in A star algorithm also to some extent there is a prediction. This prediction will happen when you compute the distance between the current state to the goal state. Even in tic-tac-toe game also partially you have seen how do you predict the next step of the opponent. All this can be understood when you try to implement them in your Python. So if you type something called as tic-tac-toe game plus Python, obviously almost we have almost more than 100 different types of implementations. Just you copy the code and execute, find the strategy, and then you try to have your own strategy and you can implement your own tic-tac-toe game. So we have seen constraint satisfaction where you are propagating the constraint step by step and coming back when the assumption is wrong, and we are propagating the constraints from the starting state until unless we predict everything in the terms of goal state. That can be innate and expert system. So we call it as constraint satisfaction or send more money, whatever it may be. That is also an expert system. So whatever we have done in the third unit, like we are given some statements and we are predicting the inference, is also an expert system in the but it is a static expert system. Like every time when you have a question, you will have an answer of whether it is a true or false. It can be either 1 or 0. That type of output you will get only for complete belief systems where the probability can be either 1 or 0. But in general, when you try to process various text in the terms of NLP, every time you will not get this ones and zeros. Sometimes we need to talk about the probabilities. We need to the probability that the inference can be true is 0.6. That is the reason. If you remember, on Friday or Thursday, I started the class with uh, a small story saying that there is a king, and this king is fond of gardening, and he take cares of his garden so well, like he water the plants, he will supply the fertilizers, and some point of time he become old and he wish to find his successor, and he has selected 10 to 11 people, and all the 10 to 11 people are successors. They are interviewed by the plant itself. The reason is the king used to talk to the plants and flowers, and they have interviewed all this 10 to 11 and they have selected their successor. And based on a small story, or as based on an incomplete story, you need to take some inferences whether the king is sensitive, since he is taking care of his garden this much properly and this much well, obviously he can take care of his kingdom. Or the king main ambition is to take care of the kingdom, he is spending more time in the garden, he is not doing his justice to his functionalities. Many other questions we have asked. But whatever questions we can ask, that can be there can be inference in the terms of probabilities only, not with respect to ones and zeros. You can think that king is sensitive because he's sitting in garden and he's talking to the flowers and plants. But the other side, you cannot guarantee that statement. That is a fact. You can say that king is doing a great job because he's caring of this garden. At the same time, he can also take care of these people. Some disturbance was that. Okay. So you can make any number of inferences, but what inferences that we do real time is in the terms of probabilities. So there is a connect in the terms of what we learn and what exactly we do. But instantly, what actually happens when you try to do the theory is A star algorithm. When I talk about A star algorithm, I have given the values from the starting state to the current state and the current state to goal state. So you feel that since the values are already given, that is a static value. But in general, like when you try to apply A star algorithm in real time, that value has to be predicted. What is the distance between your current state to the goal state? Even the same, like whatever third unit you have done is a theoretical part, or it is a basics of what exactly an expert system has to do in the terms of inference mechanism. But coming to the functionalities, it's a different aspect. Like you are given a set of statements and you are asked to infer something at real time. So that is the reason I said a statement has an impact. Like I have a statement, that statement you need to find the meaning of the statement. You need to find the meaning of the statement in the context of what is. You need to understand a sentence in the terms of what is the earlier statement and what is the latter statement, a producer and successor. Then only you can understand the meaning of the sentence properly. If you still remember, I said about bear and bull. Like a bull has entered some place, carries some different meaning. In stock market, bull will have a different meaning. The same time bear or something like that. So obviously the context of the use of things will also change with respect to the time and with respect to the situation. So obviously an expert system has to think in that manner. So last classes, what is that we are doing is we're trying to give various examples of expert systems. So since your Friday and Saturday, most of the people are getting into CN data structures classes, we are asked to only revise in Friday and Saturday. Whatever actually we have done in the earlier classes, we have to revise that. If we take some classes on Saturday morning and Friday morning, we have to redo it on on even in Monday or Tuesday. That's what I am doing for the last 2 weeks. So we'll just follow the same nomenclature, like we'll talk about various expert systems examples, and then we'll try to find out the functions of expert systems. At a later stage, we will find out what are the phases of expert systems, what is the design of an expert system, what are the tools we are already having in the terms of how can we build an expert system. This is what we can do at a later stages. But so this class is entirely focused on what examples do you have in expert systems. The intention behind all this giving more examples of expert system is to create some interest in the subject, so that at least half of the class can start working on implementing some of AI projects or AI application at the start with basic requirements or basic functionalities. That is the reason I'm giving more examples of expert systems, and whatever expert systems that we have discussed in the last two classes, and this class was already done when we are starting the first unit. So again, the same discussion, like we have something called as crowd counting systems. You know about crowd counting systems. Like this crowd counting systems will take input as a video, and this video can be taken from your CCTV footage. And what the interest is, these CC systems or AA systems which will automatically give some outputs. What are the outputs that you get from the CSE systems is crowd counting. How much crowd was there? How many people was there? Your interest has to be something like this. So if you take a video, you could find people, you can find objects, you can find many different things. What type of features are needed to identify a person, and what type of features are needed to identify infrastructure or something which cannot move? What are the other things that are needed to find something which will move in the terms of vehicles or some other people? So a crowd counting system is a system which will give the count of people instantly within zero point zero 0.07 nanoseconds. Apart from that, it will also give you people with abnormal actions, malicious actions, which at some point of time can damage the infrastructure, or they can attack some other people, and which will cause, they may cause nonsense uh, based on the actions that are trained. So the CC systems is the most important part of research now. So we call that as crowd counting systems, where the title is very simple, but the functionality is very complex, because this crowd counting systems will operate online automatically, visualizing the videos at real time. So you need to process the video, and you need to give the count, and the count has to be will be updated based upon the user requirements, but initial count you can get within zero point 0.7 nanoseconds of once you process the video. And you need to, it will also give you the things about abnormal actions, what type of what are the legal actions that we have trained, what type of abnormal actions people are having. And it will also identify the people with this abnormal action, so that people can we can protect our infrastructure. And we can also, it will also find the abnormal actions in the terms of how many people can attack, and how many people will create some disturbance in the terms of what actually happening there in the terms of event or whatever it may be. So the abnormal actions are based on the training that you have given. And CC systems are the most important systems at this moment. Most of the people are working in the CC systems. So when you wish to work in the CC systems, you need to understand like what Python library is supporting videos, because you need to understand video is a collection of images. So you need to understand like when I wish to create an expert system, at least I need to process text, and I need to process voice. Many systems will process voice. I need to process images. I need to process videos. So at the initial stage, when you wish to propose, or when you wish to design an expert system, the first thing you need to do is you need to find some libraries, or find statements which will support the processing of this, and what type of algorithms will work for this. So obviously once you identify this, obviously slowly you can just start designing the systems in the terms of small functionalities, and you can add the functionality so that the system will become complex. At the same time, when the functionalities are more, the usability of the system will be more, in keeping eye in with respect to the robustness, the adaptability, or something like that. So my interest of keeping these CC systems in the slides is you have systems which process video, and in this video you need to identify the people, and what type of features are needed to identify the people, what type of features are identified to are useful for identifying infrastructure, what type of features are needed to identify the things which will move in the terms of vehicles or some other things that are there in that video, and how many people can be identified as humans, and you can have also animals. How do you identify all these things? And it had to be done in real time. So that is what your CC systems will do. So then we will talk about mycin. Most of the people know that mycin is an expert system pertaining to health sector. So many outputs are there. That's what we have discussed about mycin earlier. Based upon the functionalities that mycin will have, almost mycin will have 250 different types of functionalities. So I can give set of symptoms, and this mycin will also give what type of disease that is attributed to the symptoms. It can assist the doctors prescribing the medicines without side effects, which is very important feature of this mycin. Once you give the DNA sequence in the terms of blood sample, it will also give you whether is there any chance that you are prone to cancer or not. And once the analysis was complete, it can also give you what type of cancers you can get, whether it is a breast cancer or a bone cancer or any other cancer, blood cancer or whatever it may be. It can give the details. So your mycin initially used to interact with people in the terms of text. Now the mycin is interacting with people with respect to voice also. Now this is very important. Now when you try to design an AI system or an expert system in the terms of app or any system with limited features or more features, now the mandatory thing is the system needs to process the voice. Earlier we used to interact with the system with chatbots or whatever it may be in the terms of text, but now this text has gone and now the interaction has done with voice. So mycin can uh, read the voice, it can process the voice, and it can give you the disease. What is the disease? If you are having 6 fingers in the hand, what is the reason for 6 fingers? If you are suffering with chronic disease, what is the reason for that? So my intention of this classes is how an expert system is designed. The next class will be what are the phases of an expert system. So once you need to understand the phases of an expert system, theoretically you need to understand the functionalities of expert system, how the expert systems are classified, what is an expert system, what is an ordinary system. All this theory will come at a later stage. Since we have discussed about various aspects of expert systems, I'm just continuing the same phase so that at some point of time you could find different expert systems in your own domain. Like last classes, if you remember, I said for COVID also, for COVID monitoring also we have expert systems now. If you type something called as COVID plus social distancing, you will get more expert systems. Like in an enterprise, if somebody wish to find out whether the employees or people are practicing social distancing norms or not, we have a system which process the video and can give you how many people are practicing the norm or not. I also said we have systems in deep learning which will also process the videos and it will give you whether the people are practicing this mask nomenclature or not. If they have masks, whether the masks are properly kept or not. All these are the expert systems. All these are the applications of expert systems now. So learning, see, that's what I said. What is the outcome of the entire artificial intelligence subject? If you remember, I said if the outcome of the entire AI subject is to design an expert system. Expert system name itself looks big, but the overall understanding is very simple because you have 6 phases in the expert systems. All the phases will have some tools. That's what we are going to discuss in the earlier next classes. So if you wish to design a small expert system pertaining to a stock market or weather prediction or healthcare app, already inbuilt tools are already available. So you can just download that tools and you can just customize based on your requirements. So expert system design is very easy. That is the reason you ask your seniors. They have started, they have designed many AI based systems whenever they participate in Microsoft uh, hackathons or Microsoft contests. They have designed these AI apps and systems where the emphasis is in expert system. How do you process a video? How do you extract data from images? All these are expert system design tasks. So I'm just coming back. Like even when you try to address the COVID issues, like I wish to scan the X-ray of a patient, and I wish to find out whether this X-ray is prone towards COVID or not. You have an expert system in deep learning. So obviously, many real-time problems can be solved by using deep learning and artificial intelligence, machine learning. That is the reason you take any problem, a general problem, where the text or voice or images or video are the inputs, then definitely you have a solution in machine learning or artificial intelligence or deep learning. That is the reason. If you remember the last classes when you're talking about crop disease prediction, you wish to find out them and monitor the crops that are there in your house. You can take the healthy leaves, like you wish to monitor a paddy crop. You can take the photos of a healthy paddy crop and a diseased paddy crop, and you can process and say that at some point of time this paddy crop now can be diseased, so it is the high time for you to go for a fertilizer. And when this paddy crop is in reap, like when what type of yield you will get if you ripe today, and what type of yield you will get if you ripe the crop after 2 or 3 days. All these are real-time applications, and all these expert systems can be designed for this type of problems. So once mycin, I will get back to this IBM Watson, whereas IBM Watson initially was into health sector, where again whatever functionalities that mycin can do, it can also do. But IBM Watson can interact with more. It is a question and answer mechanism where IBM Watson will also give you the mindset of some point of time at this moment based on the questions that it has asked, and based on the answers that you have given. Like Eliza, how are you? Are you feeling great? It see you can interact because it's IBM Watson is available online. Once you interact with IBM Watson, I can just find out what type of mindset people will have at that moment, and it can give you various inferences about the health of particular person. My health details are with IBM Watson every time. My health reports are updated. So obviously, what type of diseases that you can have in future, that prediction is the accuracy of that prediction is almost 70, more than 76% as per the website says. And not only this, IBM Watson is into this health sector. Now IBM Watson is can be used like uh, as what is that voice app, or it can be voice customization, like whatever voice customization apps you have, something like Alexa, Siri and Google Home. This can be your voice assistant also. IBM Watson can act as a voice assistant. IBM Watson was into automobile industry. What type of infrastructure can fit into this part? So slowly, mycin was restricted to health sector, but IBM Watson is just into different sectors, where it was into health sector, it was into psychology part, it was into automobile industry, it was into voice assistance. So many other different functionalities are there. But the interest that you need to understand here is once IBM Watson initially used to again interact with text, but now it is interacting with people in the terms of voice also. It is what you need to understand. So if somebody like you uh, wish to process some text or voice, can somebody just tell me what language will be helpful for you to implement an expert system? Can just somebody type in the chat box, because sometimes I'm just not interacting with the people going in the class. Yes, Python is one of the languages where you can build an expert system. Any other language, can you build expert systems in Java? See, you can build. expert systems by using Prolog. Initially, when we are doing our BTech, we used to say that Prolog itself is an expert system language. Now, whatever the activities that are done by a Prolog can be done itself in Python itself. So, we have some expert systems that are designed in Java. Now, what is actually happening is expert system design layout is done by your augmented reality. Like you need to have a different feel of the systems. You can have a augmented reality. That is the reason most of the people are working in C sharp and Python to build in different expert systems. Many expert systems are there. So most of the expert systems now they are developing, whether it is a COVID expert system or expert system pertaining to CCTVs, like I said, crowd counting systems. All these are developed by using Python. That is the reason when people wish to work in deep learning or machine learning, they work in Terra using Keras and TensorFlow platform. So just type something called as Keras and TensorFlow in the terms of Python, and how can we use this? If you just try to find out what is that, what is cyclic learn, and what exactly is, how does Python supports machine learning algorithms, then obviously most of the people will be inclined to work in this area. So each alarm mechanism is a mechanism. Generally, this has to be this is approved by the government of India, where this each alarm mechanism is a mechanism which process video and which was augmented with the speed gun. This is what we have discussed. So each alarm mechanism is a mechanism where we need to supply a chelon to the vehicles which are crossing the prescribed speed. This is what it is. So what is the people has done is in a Kolkata highway, what they have done is they have kept the CCTVs, and the CCTVs are augmented with the speed guns. Whenever a vehicle exceeds the speed, your speed gun will interact with the CCTV, and CCTV footage they will take, and from that CCTV automatically that video will be converted in the set of images, and from that images the most important thing is they extract the text pertaining to the car number, and they will search the corresponding email of the car number, and automatically I think I have a small technical problem. Can you hear my voice now?
Yes, sir.
Yes, yes. Thank you very much.
Yes, sir.
Okay. We'll just go. Okay, okay. Thank you. So, my interest of taking this class in detail in the terms of expert systems is expert system classes. What is that we do is we give the definition of an expert system. We straight away start the phases of an expert system, and many other things we'll do. But instead of that, even when I start AA classes, also my emphasis is how do you give the functionalities of each system, and what can be the input of each system, and how can your AI system will give you. See, when we try to predict the weather forecasting or whether you try to predict a crop, there is a sensor called as moisture sensor which can interact with the system. We call it as we will take the help of IoT, where moisture sensor will interact in the terms of Arduino or Raspberry Pi. It will interact with the system and it will give you a message that this is the amount of moisture that was there at that moment. So your interest has to be how can a system can interact with sensors, how can a system can interact with a speed gun. It's very simple. And then once the speed guns found that this car is exceeding the speed which was a threshold speed, so obviously then it has to store the details, the video of that car, and it has to convert the video into set of images, and it has to find the image where the card number was there, and then based on the card number it has to be automatically send an email to the person based on the amount of speed exceed that based on that situation. So obviously what is my interest is when you try to design an expert system, you need to process videos as far as ETL mechanism is concerned, and the expert system also will coordinate with a speed gun. But interesting fact is everything was done automatically, and the email to the owner has to be sent with less than 2 milliseconds. This is what the performance of the system is. So you need to monitor the cars and vehicles that are passing that CCTV, and based on the speed, you need to just try to extract the video and get the particular image. From that image, you have to get that text. From the text, you need to find the corresponding email, and you need to send a mail within this 2 milliseconds. It's very difficult, and this is what that is the reason it's very difficult to process videos automatically. So each element mechanism is the most important expert system which will do the things with more accuracy and with respect to the time. Also I mentioned CCTV systems also I said within 0.07 nanoseconds it can find out how many people are there in that video. So I also said about crop disease prediction. So artificial intelligence can be, you have many applications of AI in the terms of agriculture. Like you have seen some pictures last time when I kept like your drones are fertilizing the crops, and your drones are taking the pictures of the crops, and where the pictures can be scanned and just try to find out whether what is the status of the crop. Based on the pictures that are taken by drone technology, we can just find out whether this crop is prone to diseases or not. Not only this, crop prediction, disease prediction can be done by using image processing. It can be done by using weather also. You can also predict the weather of a particular place. Based on the weather variations, the crop fertility or crop yield will change. So this was discussed in detail in the earlier classes. So obviously this disease prediction, the input is an image. So you can find the healthy images of paddy, and you can also get the diseased images of the paddy, and then you can process and say that this yield of the crop is this much. Apart from that, the crop diseases or crop yield can be done by based on the weather predictions of weather also. So how much of adequate temperature and what is the adequate water so that this crop can give a more yield, and what is the weather prediction or weather content now, and based on that you can also predict the weather. Based on that we can predict the yield of the crop also. So obviously the crop prediction will be one expert system where you can you wish to work on, you can also apply this. But the interest is how do you process the weather parameters or how do you process the images? This is what you call it as a crop prediction system. Most of the time we use CNN when you try to monitor these crops in the terms of images. When you try to have whether I can go for RNN because you have a sequential data there, recurrent neural networks and convolutional neural networks that will come in machine learning and deep learning that we can discuss at later stage. As far as these classes are concerned, you need to understand the functionalities of expert systems, what function these systems has to do, and what is the input for this, and what can be the output for this. And you need to understand that all these are automatic systems which will alert the people. So we have seen many recommendation systems. Like I said, you have browsed some e-commerce websites online. What does this e-commerce websites do is they will learn from the searches that you do, and they will try to suggest and predict what type of good that you are going to procure in a later stage, and what type of systems or what type of goods they can recommend. See, this is an AI system actually. They are learning from the customer. You type uh, recommendation systems plus Google, you have three different types of recommendation systems that Google will follow. One is based on the way in which you search. The other one is the sensitivity of the customer and how far. Like I wish to buy something called as a printer. How many times the customer has searched about the printer there? How many times he has procured? What type of belief system that a customer has maintained? All these things will be coming into the recommendation systems. And many times we spoke about this Hawkeye, and Hawkeye is a AI system which will process the video in real time, and it will give you the displacement or deviation of a particular ball after pitching, how much of deviation it can take, how much of displacement it can take, how much of height it will travel once it was pitched. All these things, most of the Hawkeye systems, not only in cricket, most of the other sports also uses this Hawkeye. But the intention of this Hawkeye is like printing something in online, processing a video. It can be the displacement of the ball, it can be the deviation of the ball, it can be the height of the ball after pitching. Many other aspects are there. The interest is something like how do you process things at real time, and the processing element is a video. So we'll take some 2 or 3 questions now. So what technique is used in voice processing system, and is Hawkeye a video processing system? So the answers are very simple because we have discussed this part. So what technique was used in voice processing systems? If somebody wish to process a voice in general, straight away I can use a system, we call it as RNN. Even now people are using this CNN also for processing this voice. Straight away we have various library functions in Python which can process voice, and it can tell you, see, I have given a voice, can this voice is pertaining to a kid, or whether this voice is pertaining to old, or if this voice is pertaining to a marginal person with an age of 20 to 30. You can have different types of inputs and you can get different types of outputs. But the intention that I kept in this system, in this question, is something like this. Because whatever AI system that you wish to develop, most of the AI system has to process the voice. Whether it is Alexa or Google Home or Siri or any other expert systems, most of the system has to process voice. So you need to find out what systems will support voice and what are the ways in which I can process the voice. That is the reason I kept this question here. And the second question is more simple. Like I have said, Hawkeye is a video processing system. Yes, it is a video processing system, but like your CC systems and each-channel mechanism, this is a video processing system that gives the output automatically. Once it processes a video, it can tell you how much deviation that the ball can take, how much displacement it can take, and it will also tell you how much height it will travel after pitching. So all these are predictions. The displacement, deviation, and the height are all are predictions that will happen at real time. So like Hawkeye, we have other systems which are pertaining to COVID, CC systems. Most of the systems that I am talking are interesting systems which will process the videos. So we have 2 or 3 expert systems that I have to discuss. We will discuss tomorrow. Then what is that I do tomorrow is we will discuss 2 or 3 expert systems and start these phases of expert systems. We have 6 phases of expert systems, starting from generalization, what type of knowledge is needed, what type of statistical knowledge is needed, what is the role of inferences in that. Do we need a specialized inference? What is the role of knowledge acquisition? What is the role of human expertise when you try to design an expert system? This type of discussion will happen in the next class. So the next class, the emphasis will be on the phases of an expert system. Before having this expert system phases, I just tried to find out what is Deep Blue and what is Tesla and Sophia, and then we'll get back to these phases of an expert systems. So before that, I just request you to answer this uh, quiz that was posted in this chat box. Please answer the questions in this, and then you can just try to join in the next class. Before that, I'll just try to find the attendance. Please answer the quiz, answer the questions, then you can just try to leave the class and join in the other class. If you have any doubts, please unmute yourself, but answer this quiz questions and then leave, because I'm taking the attendance from this quiz itself.